All right, so now we're going to look at gases, and we're going to look at something called gas laws. What we talk about will be general gas laws. We will get into the math of them individually as we go on. So when you inhale, the volume of your chest cavity increases and air moves into your lungs. When you exhale, the volume of your chest cavity decreases and air is pushed out of your lungs. Changes in the volume, the temperature, the pressure, and number of particles have predictable effects on the behavior of gases. What causes gas pressure in a closed container? Gas pressure or pressure is the result of a force distributed over an area. Collisions between particles of a gas and the walls of the container cause the pressure in a closed container of gas. So the more collisions, the more pressure you have. So a moving hockey puck exerts pressure on any object it hits. A layer of shatterproof glass protects spectators. The faster the puck is traveling, the greater the force of the puck on the glass. A greater force means more pressure. The smaller the area of impact is, the greater the pressure. If the edge of the puck hits the glass, it exerts more pressure than if the face of the puck hits the glass. The SI unit of pressure is derived from SI units for force and area. Force is measured in newtons. Area is measured in square meters. The SI unit for pressure, the Pascal, is shorthand for newtons per square meter. Scientists often express larger amounts of pressure in kilopascals. 1 kilopascal is equal to 1,000 pascals. We'll review those before we do any math. The helium atoms in a balloon are constantly moving. There are more than 10 to the 22nd helium atoms in a small balloon. When many particles collide with the walls of a container at the same time, they produce a measurable pressure. The more frequent the collisions, the greater the pressure is. The speed of the particles and their mass also affect the pressure. What factors affect gas pressure? Factors that affect the pressure of an enclosed gas are its temperature, its volume, and the number of particles. Temperature. Raising the temperature of a gas will increase pressure if the volume of the gas and the number of particles are constant. A firefighter is using a pressure gauge to check the air pressure in a tire on a fire truck. If he checks the tire pressure again after a long drive on the highway, he will find that the pressure has increased. The motion of tires on the highway heats the tires and increases tire pressure. As the temperature rises, the average kinetic energy of the particles in the air increases. With increased kinetic energy, the particles move faster and collide more often with the inner walls of the tires. Faster moving particles hit the walls with greater force. More collisions and increased force cause the pressure of the air in the tires to rise. Reducing the volume of a gas increases its pressure if the temperature of the gas and the number of particles are constant. Twist the cap onto a plastic bottle and then squeeze it. What happens? The volume of the plastic bottle begins to decrease. As the volume decreases, the particles of the trapped air collide more often with the walls of the bottle. The pressure in the bottle increases. Movement of a muscle called the diaphragm changes the volume of your chest cavity. The volume increases when you inhale. The pressure decreases and air flows into your lungs. The volume decreases when you exhale. The pressure increases and air flows out of your lungs. So here you go. So when you inhale, your diaphragm contracts and it opens up your lungs. When you exhale, the diaphragm pushes up and it gives you less volume. Number of particles. Increase the number of particles will increase the pressure of a gas if the temperature and the volume are constant. The more particles there are in the same volume, the greater the number of collisions, and therefore the greater the pressure. Charles's law. French physicist Jacques Charles collected data on the relationship between the temperature and volume of gases. The graph of the data showed a direct relationship between the volume of a gas and the temperature of a gas. Charles extended the graph beyond the measured data. So let's and to find the temperature that would produce a volume of 0 liters. The temperature at the point where the line crossed the x-axis was negative 273.15 degrees Celsius. So let's take a look at this. Here are the data points that Charles got. And you can see it's pretty much a straight line, which shows as temperature goes up, volume goes up. So he drew a straight line. Then he took this line and extended it out. And what he found was this number, when you to have a volume of 0, you had negative 273.15. This temperature is equal to 0 Kelvin on the Kelvin temperature scale. A temperature of 0 Kelvin is called absolute zero. So that's where high absolute zero was discovered. Charles's law states that the volume of a gas is directly proportional to its temperature in kelvins if the pressure and the number of particles of the gas are constant. So here's Charles's law: volume, temperature, volume, temperature. This is the, then they see the 1, right? T1, V1 represent the temperature and volume before a change occurs, and then V2 and T2 are after the change occurs. Again, we'll do the math of this on a different day. Boyle's law. Robert Boyle discovered the relationship between the pressure and volume of a gas. The graph shows an inverse relationship between the volume of a gas and the pressure of a gas. So as pressure went down, volume increased. Lower the pressure, the greater the volume. And he got this line, which means it's a inverse relationship. So Boyle's law states that the volume of a gas is inversely proportional to its pressure if the temperature and number of particles are constant. Again, P1 and V1 are the pressure and volume before the change, and then P2 and V2 are the pressure and volume after the change. And again, we'll do the math with this on a different day. And then the combined gas law. The relationships described by Boyle's and Charles's law can be described by a single law. The combined gas law describes the relationship among the temperature, volume, and pressure of a gas when the number of particles is constant. Again, this is before the change, this is after the change. Balloons like this one are used by scientists to gather data about Earth's atmosphere. The balloon is filled with hydrogen or helium. It carries a package of weather instruments up into the atmosphere. The gas laws explain the behavior of the gas in a balloon.